Assalamu alaikum warahmatullahi wabarakatuh. My name is Muad Umar Muhammad Hadi with name ends with 069. Today I'm gonna be presenting my take-home UTS for biomedical computation for PE1. So I'm gonna present the first question. Uh, Find the power law relation between animal mass and its metabolism. So the data below will show the mass of some animals and its rate of metabolism to kill the calories or burn, to be more specific, the calories. We'll also have to take the natural law of all the independent and dependent variables. So we're gonna have to take the natural law of the mass and the natural law of the metabolism rate. So uh, going to the manual writing. After taking the natural log of each of the mass and the Lego, we end up of the natural log of 6.55, 4.24, 4.007, 2.708 minus 0.91. For the natural log of the metabolism rate, we have 9.372, 7.438, 7.2979, 6.579, 3.401. So assuming the mass is the on the x-axis and the rate on the y-axis, we establish that the mass is x. So we have the total of x is combining all the numbers. So we'll have 16.595. And for the metabolism rate, which is y, we add up all the natural log of the numbers provided. We'll end up having 34.069. Also, we'll have to take the total of multiplying x and y of each step or row and column, assuming it's a matrix. We'll have 136.8111 and taken the total of x squared is 85.097. Calculating the slope, which given uh, given the letter A is in the total of the حيوان or animals, which is 5, multiplied by the total x and y minus the total of x multiplied by the total of y over n multiplied the total of x squared minus the total of x squared. Well, the slope will be around 0.79. For the intercept, we'll take the total of y minus the slope multiplied by the total of x over the number of uh, animals will be around 4.19. So the total is y is equal to x that's multiplied by the slope plus the intercept, which is 4.19 plus x 0.7. So going to MATLAB for creating the code for this problem. Okay. So to start, we'll have to calculate the mass. Calculating the mass, we have The numbers are 770, 55, 15, 0.4 volts. Uh, we down there's it down 176, 170, 450, 720, and 30. So to start, we're gonna have to take the natural log of each of these. So log log and log mass log s. Okay. To show the total, we're gonna have to uh print it here. If if uh, log mass kilogram in display. Of it, to check the answer. Okay, then next we'll have to take the coefficient. So coefficient. Uh, we're gonna use the function called polyfit. Sorry, wait, polyfit, which show the row of one normal uh distribution, or for this function to be in the first order, and it's gonna have to be a linear, so it's gonna be one line. This show the coefficient of the slope and the coefficient of the intercept. So by this function, we're gonna have to uh, add the mass, no, the log mass, and the log mean, and one, which means it's only one line, so it's gonna only get the coefficient from that line. For taking for example, A, the coefficient of 1 for the slope, and B, coefficient of 2 of the intercept. To show this, we're gonna have to print, uh, oops, sorry, low rate power relationship uh, is, and then 8 equal to sorry, f multiplied by log minus plus what's it again? F and then A and B, which show that the slope around s- sorry, the log of metabolic rate is about 0.789, which is which can say y is equal to uh, the slope multiplied by the x or mass plus the intercept. So intercept here is 4.1924 and the slope is 0.7897. So it's much similar to our calculation before. However, in here is with more details because we got 0.79 and for the intercept 4.19. So the method is really similar because they both use the log function to get the actual rate. After that, they take uh, the calculation from the from the slope and intercept to get the specific rate of the mass that is burned down from the metabolic rate. I would also show the code for the second answer, which is uh, A, the uh, uh, K, sorry, KL for the Y, W, X, and Z, and this for F. So we're only gonna need to uh, divide A over F and taken the display the result of Y for the first column, uh, W for the second column, X for the third, and Z for the fourth. And with this, we'll show also the answer, which is 15, 13, 18, and 20. For the mathematical way, we're gonna uh, use Gauss elimination to get the answer. So we're gonna put it as matrix, and with after calculation and getting the answer, we'll show that it's the same answer as the code. And that's everything. Thank you so much for listening for this video, and hoping you're having a great day. Thank you.